In the mid-1970s, Chicago's commuter rail network faced a problem that couldn't be solved with existing equipment. The city's railroad operators needed locomotives capable of rapid acceleration with heavy consists, reliable electrical generation in sub-zero temperatures, and the durability to withstand decades of intense daily service. The solution came in the form of 15 unusual machines that looked more like freight locomotives than passenger units. This was the EMD F40C, a six-axle 390,000-pound commuter locomotive built to freight-grade standards. It was one of the heaviest passenger diesels ever constructed for commuter service in North America, and despite performing its duties reliably for nearly 2 decades, it remains largely forgotten outside enthusiast circles. The F40C represents a unique moment in American railroad history, when one operator chose brute strength over efficiency, and when head-end power technology was still in its infancy. This is the story of why it existed, how it worked, and why it had no successors. Before we continue, if you think our content is unique and informative, please leave a like and subscribe. It really helps support the channel. Also, make sure to share the video with other train fanatics out there. By the early 1970s, the Chicago and Northwestern Railway was operating one of the busiest commuter rail networks in the United States. The CNNW moved tens of thousands of passengers daily across 3 major routes radiating from Chicago's downtown terminals. The service pattern was demanding, frequent stops, tight schedules, and operation in some of the harshest winter conditions in the country. The railroad's existing motive power fleet was aging rapidly. First-generation diesels like EMD FP7s and E units, some dating back to the 1940s and early 1950s, were showing their age. These locomotives had been designed primarily for long-distance intercity service, not the constant acceleration and deceleration cycles demanded by commuter operations. Maintenance costs were climbing, and reliability was declining precisely when ridership was increasing. A critical technical problem centered on passenger car heating and electrical systems. The older locomotives used steam generators to provide heat to passenger cars, a system inherited from the steam locomotive era. These steam generators were maintenance-intensive, prone to failure in cold weather, and inefficient. The electrical systems were similarly problematic, with aging generators struggling to provide consistent power for lighting and climate control systems. Head-end power technology was emerging as the solution to these problems. Rather than generating steam, HEP-equipped locomotives would provide 480-volt alternating current electricity directly to passenger cars for all heating, cooling, and electrical needs. This was more reliable, easier to maintain, and better suited to modern passenger car designs. However, in the mid-1970s, HEP technology was still relatively new to American railroading, and few locomotives were designed from the ground up to accommodate it. The CNNW's service requirements added another layer of complexity. The railroad operated long consists of heavy bi-level gallery cars. Some trains exceeded 600 tons loaded. These trains had to accelerate quickly from station stops to maintain schedules on routes with frequent stops. In winter, when wheel rail adhesion deteriorated on ice-covered tracks, the challenge became even greater. The railroad needed locomotives with exceptional low-speed tractive effort and excellent adhesion characteristics. Most contemporary passenger locomotives were 4-axle designs optimized for high-speed intercity service. The CNNW concluded that they needed something different, a locomotive built with the durability and traction capabilities of a freight unit, but equipped to handle passenger service electrical demands. This unusual set of requirements would lead directly to the F40C's distinctive design. When the Chicago and Northwestern approached EMD in the early 1970s, they made an unusual request. They wanted a 6-axle passenger locomotive, a configuration rarely seen in American passenger service. The additional axles would distribute weight more evenly, reduce wheel slip during acceleration, and provide better adhesion in adverse conditions. Most importantly, the railroad wanted freight-grade durability. They weren't interested in a lightweight locomotive optimized for high speed. They wanted a machine that could withstand decades of intensive commuter service. EMD's response drew heavily on the engineering philosophy of the SD-42, which was rapidly becoming the standard heavy freight locomotive of the era. The SD-42's robust design, proven reliability, and excellent maintenance characteristics made it an ideal starting point. However, the F40C would need substantial modifications to serve passenger duties while retaining that freight-grade foundation. The decision to use 6 axles had several technical advantages beyond improved adhesion. 6 axles distributed the locomotive's substantial weight more evenly across the rail structure, reducing peak axle loads and minimizing track damage, an important consideration given the F40C's eventual weight of approximately 390,000 pounds. The configuration also provided smoother starts and better ride quality at lower speeds, though it did limit top speed capability compared to 4-axle designs. For commuter service, where trains rarely exceeded 70 miles per hour, this trade-off was entirely acceptable. One of the F40C's most significant design features was its integrated head-end power system. Unlike earlier conversions where HEP equipment was retrofitted to existing locomotives, the F40C was designed from the outset to generate passenger power. This allowed EMD to optimize the entire electrical system rather than compromising with add-on equipment. The locomotive would have no steam generator. It was a clean sheet design for the HEP era. EMD delivered the first F40Cs to the CNNW in 1974. The railroad ultimately received 15 units, numbered 101 through 115. These locomotives shared many components with contemporary freight units, including the basic frame structure, truck design, and engine auxiliaries. However, they incorporated passenger-specific features like multiple unit capability, compatible with existing commuter equipment, passenger train air brake systems, and the dedicated HEP generation equipment. The F40C emerged as a hybrid design, unmistakably a passenger locomotive in its mission, but built with the structural strength and component durability of a freight unit. This approach would prove both its greatest strength and ultimately its limitation. At the heart of the F40C was the EMD 16645E3 prime mover, a 16-cylinder 2-stroke diesel engine rated at 3,200 horsepower. This was the same engine family used in contemporary freight locomotives like the SD-42, known for exceptional reliability and ease of maintenance. The 645 series engine had been refined over more than a decade of service and represented mature, proven technology. The engine's 3,200 horsepower rating required careful allocation between traction and head-end power. The F40C's electrical system was engineered to provide approximately 500 kilowatts for HEP while maintaining sufficient power for traction. This meant that under full electrical load, somewhat less than the full 3,200 horsepower was available for moving the train. But EMD's engineers had calculated this trade-off carefully to ensure adequate performance in typical service. The HEP system itself represented advanced engineering for its time. The F40C used a dedicated alternator driven by the main engine to generate 480-volt, 3-phase alternating current at 60 Hz. This system could supply power continuously without depending on variable engine speeds, a significant advantage over some early HEP installations that struggled to maintain consistent electrical output during acceleration and deceleration. The electrical system was designed to power an entire consist of modern commuter cars, with air conditioning, electric heating, and full lighting. The locomotive's frame and underframe structure were built to freight standards, resulting in the F40C's remarkable weight. At approximately 390,000 pounds, it was one of the heaviest passenger locomotives ever built for commuter service. This wasn't excess weight, it was structural steel designed to withstand decades of service under the most demanding conditions. The heavy frame contributed directly to the locomotive's excellent adhesion characteristics and resistance to wear. The F40C rode on 2 3-axle flexi-coil trucks, a design derived from freight locomotive practice. These trucks provided the 6-point contact with the rail that gave the locomotive its superior traction characteristics. The truck design allowed some lateral motion to navigate curves while maintaining good weight transfer characteristics during acceleration. The additional axles meant more wheels applying power to the rail simultaneously, reducing the likelihood of wheel slip that could delay acceleration from station stops. Inside the cab, the F40C made no pretense of being anything other than a working locomotive. The environment was loud. The 645 engine was directly behind the cab wall with minimal sound insulation. Ventilation was basic, and in summer, cab temperatures could become uncomfortable. The control stands and instruments were functional and straightforward, with none of the refinements found in dedicated intercity passenger locomotives. Crews described the F40C cab as industrial and utilitarian, a freight locomotive cab adapted for passenger service rather than a purpose-designed passenger environment. The fuel capacity was substantial, with tanks holding approximately 2,400 gallons of diesel fuel. This was necessary given the F40C's relatively high fuel consumption, which resulted from both the engine's continuous operation at high output and the locomotive's heavy weight. The fuel system included multiple filters and water separators to protect the engine from contamination, critical for maintaining reliability in daily service. The F40C's air brake system was designed for passenger service with dynamic braking capability. The dynamic brakes allowed the locomotive to assist in train braking by converting the traction motors into generators, dissipating energy as heat through resistor grids. This reduced wear on the friction brakes and provided smoother deceleration, important for passenger comfort during frequent station stops. The F40C entered revenue service with the Chicago and Northwestern in 1974, and its performance characteristics quickly became apparent. The locomotives excelled at their primary mission, accelerating heavy commuter trains from frequent station stops. The combination of high horsepower, six-axle traction, and substantial weight gave the F40C exceptional low-speed pulling power. Crews reported that the locomotives could accelerate loaded consists smoothly and rapidly, maintaining the tight schedules demanded by Chicago area commuter service. Acceleration performance was particularly impressive with the railroad's bi-level gallery cars. A typical consist might include 8 to 10 of these heavy cars, resulting in the total train weights exceeding 600 tons. The F40C handled these loads without apparent strain, delivering strong, consistent acceleration even from a standing start. The six-axle configuration meant wheel slip was rarely a problem, even in less than ideal rail conditions. Reliability proved to be one of the F40C's strongest attributes. The freight-grade components and heavy construction paid dividends in daily service. The 1664 E3 engine was a known quantity with a strong maintenance support network, and CNNW's mechanical forces were already familiar with similar engines from freight operations. Major mechanical failures were uncommon, and the locomotives accumulated impressive availability rates throughout their service lives. Winter operation revealed the wisdom of the F40C's design philosophy. Chicago winters are severe, with temperatures regularly dropping below 0 Fahrenheit and ice forming on rail surfaces. The F40C's substantial weight and six-axle configuration provided excellent adhesion even on ice-covered rail. The HEP system delivered consistent electrical power without the cold weather failures that had plagued older steam generator-equipped locomotives. Passenger cars remained warm and well lit even in the coldest conditions, a significant improvement over the previous generation of equipment. Crew opinions on the F40C were mixed but generally positive. Engineers appreciated the locomotive's power and reliability. The strong low-speed pulling capability made their job easier, and the locomotive's predictable handling characteristics inspired confidence. However, the cab environment drew consistent criticism. The noise level was high, with the 1645 engine producing significant sound and vibration. Ventilation was minimal, making summer operation uncomfortable. Crews often described the F40C as feeling like a freight locomotive pressed into passenger service, which was, in essence, exactly what it was. The locomotives did have operational limitations that became more apparent over time. Fuel consumption was high compared to lighter passenger locomotives, a consequence of the heavy weight and powerful engine operating continuously at high output. For a railroad managing tight budgets, this operational cost was significant. The locomotives were also somewhat inflexible. They were optimized for heavy commuter service and weren't well suited to lighter consists or routes where their full capability wasn't needed. Maintenance access was another area where the freight locomotive heritage showed. While the components themselves were reliable, some systems were more difficult to service than in purpose-designed passenger locomotives. The tight packaging of equipment and limited cab access points sometimes complicated routine maintenance. However, the simplicity and robustness of the basic design generally offset these concerns. Despite these limitations, the F40C fulfilled its mission effectively. Throughout the 1970s and 1980s, These 15 locomotives moved hundreds of thousands of commuters across the Chicago area. They maintained schedules, provided reliable service, and demonstrated that head-end power technology could work effectively in intensive commuter operations. The F40C proved that its unconventional design approach was viable, even if it wasn't ultimately the direction the industry would take. The F40C's 15-unit production run would prove to be the entire production history of the design. No other railroad ordered the type, and even the Chicago and Northwestern didn't acquire additional units after the initial batch. Several factors contributed to the F40C becoming a unique design rather than a widely adopted standard. Weight was perhaps the most significant factor limiting the F40C's appeal. At 390,000 pounds, the locomotive imposed substantial loads on track structure. While this weight contributed to excellent adhesion and durability, it also accelerated track wear and increased maintenance requirements for the infrastructure. Lighter locomotives could reduce these costs significantly, an important consideration for cash-strapped commuter operations and Amtrak, which was dealing with deferred maintenance on inherited track infrastructure. The F40C's high fuel consumption also became a liability as operating costs came under increasing scrutiny. The 1970s oil crisis made fuel efficiency a priority across the transportation industry. The F40C's heavy weight and continuous high-power operation resulted in fuel consumption rates that were difficult to justify when lighter, more efficient alternatives began to emerge. Technological developments in head-end power systems and locomotive engineering made the F40C's brute force approach less necessary. By the late 1970s, EMD had refined HEP technology to the point where lighter four-axle locomotives could reliably provide passenger power without the structural overhead of the F40C design. Improved electrical systems, more efficient alternators, and better integration of HEP equipment into lighter locomotive platforms made six-axle passenger locomotives unnecessary for most applications. The emergence of the EMD F40PH as the standard American passenger diesel locomotive effectively ended any possibility of F40C follow-on orders. The F40PH was a four-axle design that weighed approximately 260,000 pounds, over 130,000 pounds lighter than the F40C. It could still provide adequate HEPs and had sufficient power for most passenger operations, including Amtrak's intercity services. The F40PH was simpler, cheaper to operate, and easier to deploy across diverse route structures. When Amtrak began large-scale F40PH procurement in the late 1970s, it effectively established the four-axle HEP locomotive as the American standard. The F40C's small fleet size created its own problems. With only 15 units in service on a single railroad, there was no economy of scale for parts procurement or specialized tooling. Training was limited to C&NW personnel, and the expertise required to maintain the locomotives remained concentrated in the Chicago area. When the time came to consider major rebuilds or overhauls in later years, the business case was difficult to justify for such a small fleet. Changing priorities in commuter rail operations also worked against the F40C's design philosophy. As commuter agencies expanded and modernized in the 1980s and 1990s, they increasingly valued operational flexibility over raw power. Push-pull operations with cab cars became common, reducing the need for locomotives, optimized solely for pulling from one end. Lighter equipment and improved track maintenance reduced the need for extreme low-speed tractive effort. The F40C also suffered from a marketing problem. It simply wasn't visible outside the Chicago area. While F40PHs became synonymous with Amtrak and appeared nationwide, the F40C remained a Chicago and Northwestern specialty. Railroad enthusiasts knew about the type, but it never achieved the recognition of more widely deployed designs. When railroad historical societies and museums looked for representative examples of 1970s passenger motive power, they typically acquired F40PHs, not F40Cs. The story of the F40C is ultimately one of successful operation but limited influence. The locomotives served the Chicago and Northwestern reliably from 1974 until the early 1990s, when they were gradually retired as newer equipment arrived and the C&NW's commuter operations were transferred to Metra, the regional commuter rail authority. Some units received overhauls and continued in service into the mid-1990s, but By the end of that decade, all had been retired. The F40C proved several important concepts that would influence later locomotive design. It demonstrated that head-end power technology could work reliably in intensive commuter service, even in severe winter conditions. This validation helped build industry confidence in HEP systems and accelerated the transition away from steam generators. The F40C's success with integrated HEP encouraged other railroads and Amtrak to adopt the technology more widely. The design also validated the use of freight locomotive engineering principles in passenger service. While later designs wouldn't adopt the F40C's extreme approach, the lesson that robust, simple, maintainable designs could succeed in passenger operations influenced subsequent locomotive development. The preference for proven components and straightforward maintenance became industry practice. However, the F40C's influence remained indirect. The railroad industry learned from its success, but didn't replicate its specific approach. The evolution of passenger diesel locomotives went in a different direction, toward lighter, more fuel-efficient designs that could operate flexibly across diverse service patterns. The F40C represented the end of one development path rather than the beginning of another. Today, no F40Cs survive in preservation. All 15 units were scrapped after retirement, their heavy frames and components reclaimed for scrap value. This absence from the preserved locomotive roster contributes to the type's obscurity. Unlike the F40PH, which is well represented in museums and on tourist railroads, the F40C exists now primarily in photographs, maintenance records, and the memories of crews who operated them. The F40C's story deserves recognition not because it was revolutionary or because it changed the direction of locomotive development, but because it represents a moment when one railroad took an unconventional approach to solving a specific problem, and that approach worked. The C&NW needed locomotives that could accelerate heavy trains rapidly, operate reliably in harsh conditions, and last for decades. The F40C delivered on all those requirements. In the broader history of American railroading, the F40C serves as a reminder that successful engineering doesn't always come from elegant solutions or cutting-edge technology. Sometimes it comes from taking proven components, building them robustly, and applying them thoughtfully to a specific need. The F40C wasn't flashy, it wasn't widely adopted, and it left no direct descendants. But for nearly 2 decades, it quietly and reliably moved hundreds of thousands of commuters across the Chicago area, which is precisely what it was built to do.